Example 2. How many terms are there in the following sequence? So we have the beginning of the sequence, minus 8, minus 2, 4, 10, 16. That's math for etc., 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 all the way up to 88. Now, I guess in theory you could count your way up there, but you wouldn't actually get any marks for that. You've got to do it in some sort of algebraic way. So how are we going to do this? So once again, we're going to figure out, what do we know? We know that A is negative 8. The D in this case, we seem to be going up by 6 for all of these. So the D is 6. Remember, if you forget, you could just do something minus something. 4 minus negative 2, 10 minus 4. Either way, that gives you 6. So what we have is, we have T of n equals A plus n minus 1 times D. And I'll sub in those things. So T of n equals negative 8 plus n minus 1 times 6. Now what are we solving for? What else do we know? We actually know something else. What we know, we want to know, we know that the nth term, which is going to be the last term, is 88. And we're trying to figure out what is the n for that nth term. So we could actually also sub 88 in for that. So that's going to be minus 8 plus n minus 1 times 6. And now it's a question of just mathing it out, or algebraic it out, I guess. So 88 equals minus 8 plus 6n minus 6. So bring the 8 and the 6 to this side, so we're going to get 88 plus 8 plus 6 equals 6n. 6n equals 88 plus 14, 102. And divide by 6, we get 17. So n is equal to 17. So how many terms are there in the following sequence? Well, this term is the 17th term. So that means that there are 17 terms total in the sequence. Example 3. In a given arithmetic sequence, we have our T6 and we have our T13. Okay, this one's a little bit more involved. So we're actually going to look at each of those separately. So we're going to have, so T of n equals A plus n minus 1 D, and T of n equals A plus n minus 1 D. I squished one in a little bit more than the other. So what we know that T6 equals 47. So T of n is 47, and that happens when, on the 6th term, when n is 6. And similarly, we know that 93 happens when we have the 13th term. So cleaning that up a little, we have 47 equals A plus 6 minus 1 is 5D. And we have 93 equals A plus 13 minus 1 is 12, 12D. So we still have two variables, but now we have two variables and two equations. And what we could do is we could do substitution and elimination with this one. So we're going to have 47 equals A plus 5D, 93 equals A plus 12D, and this is actually beautifully set up for subtraction. So we could do this equation minus that equation. And then what that gives us is 47 minus 93 is negative 46. And that's going to give us nothing. And then 5 minus 12 is, I did that wrong, didn't I? That's 96, which means this should be 96, which means this should be 96, which means this should be 96, because I realized it wasn't going to be a pretty number here. So what we have is 47 minus 96, negative 49. Now that's going to work out a lot better. A minus A is nothing, is 0, and 5 minus 12 is negative 7D. And then we divide both sides by negative 7, and we get that D equals 7. So D equals 7. Now how do we find A? We find A by subbing that into one of those things. So we're going to have 47 equals A plus 5D. So 47 equals A plus 5 times 7. 47 equals A plus 35. And we bring that over and we get A equals 12. So putting that together, we now know that A equals 12 and D equals 7. So what is being asked here? We want to know A, what are the first 3 terms of the sequence? So the first 3 terms of the sequence are going to be 12, and then we add 7, 19, and 26. B, the formula for Tn is going to be T of n equals A plus n minus 1 times 7. Or, if you wanted to make it pretty, Tn equals, so that would be minus 7 would be 7n minus 5. And then C, it's asking for the 17th term. And the way you would find the 17th term is you would sub in, I'll do it on the first one, 17 minus 1 times 7, which is 12 times plus 16 times 7. Which is 12 plus 112, which is 124. That should actually be T17. So T17 equals 124.